We continue reviewing calculus 2. Find the limit of the sequence. Sequence is a function where the variable, in this case we call the index, are natural numbers, as opposed to series is the sum of the sequence. So sequence is just individual terms. Right, so I'll find limit. So we just find the limit. Just the same way as we do with functions. Right, now as n goes to infinity, 9 times infinity is still infinity, plus 8 is still infinity. Bottom line is the 9n is a lot bigger than the 8. So the limit, we could say that we only need to check the one that has the highest power, or in more general way we say 9n go to infinity a lot faster than a constant. Of course the constant doesn't go to infinity at all, but we write like that, so we neglect the one with the slower roll rate, and here we cancel the n, just 9 over 2, and the limit of 9 over 2 is just 9 over 2. Right, so pretty much that. Right, next we find the limit of this sequence that have the n terms given in this form. So we take the limit as n goes to infinity, negative 1 to the n power, and then we have 1 minus 5 over n. Now, as n go to infinity, negative 1 to the n power, if it is even, it will be positive. If it is odd, it will be negative. So this one will be just 1, negative 1, 1, negative 1, alternating. We call that an alternating factor. Right, now the 5 over n, 5 is a constant, n goes to infinity, a constant or a finite number divided by infinity, so this one goes to 0. So bottom line is this one go to 0 as n go to infinity, and we just have negative 1 times 1, so this one goes to 0, and we just say we have a finite number divided by something goes to infinity. So we just have 1 times negative infinity, so this is equal to just negative 1 to the n power, pretty much, because that times 1. And this one does not exist because it's alternating between positive 1 and negative 1. So does not exist. The limit does not exist. But we can say the sequence diverge. The sequence diverges. Right. Now we find the limit of this sequence. Of course, we can also write change the index n to variable x. So we work with the function. So we use all the rule that we can for a function, or we just keep the n. It doesn't matter. Right. So how do we do this? Now we look at again the roll rate n square go to infinity a lot faster than sin n. Actually, sin n doesn't go to infinity. It is only between -1 and 1. It doesn't matter. Divide by n square. So this one will go to 0. Right. So the proper way to do this is first sine of anything is between 1 and -1. What we do next is divide by n square. N square when n go to infinity, so it's not going to be 0 and it's not going to be negative, so we do not need to reverse inequality. Now 1 over n square, -1 over n square, both of them goes to 0 as n go to infinity. So we say as n goes to infinity, this one go to 0 and that one as well. So by Sui theorem, the middle have to go to infinity. Have to go to 0 as well. So as n go to infinity, sine of n over n square is equal to 0. That's that all we have for that problem. Next, find the sum of the first n term of geometric sequence. Usually when we talk about geometric series or series in general, it is an infinite series. Now this is only the first n term because that stops at a constant. So we only worry about the first n terms of the sequence. Actually, if we go from 0 to 7, that will be 8 terms, right? If we count 0, 1, 2, 3, 7, that will be 8 terms. But anyway, we do that for this summation. Right. So the formula for the sum of the first n term of geometric sequence, we write S of n geometric sequence is given by this term, or we write out this summation. Now if we multiply -r on both sides of the first equation, so we multiply r and actually multiply by -r, so that's what we have. Now if we add side by side, this term and that term cancel out, those terms cancel out, this term cancel out, so pretty much we left with the first a and -ar to the n plus 1. And on the left hand side, both of them have s sub n. By default I can say 1 times it. So when we factor out s sub n, we have 1 minus r equal to just a minus ar to the n plus 1. Factor a out, and then finally to solve for s of n, we divide by 1 minus r on both sides. So that's the formula for it. Again, it's n, but the formula is going to be n plus 1. In this formula, a is equal to 2 over 5 and r is -4. Right. So according to formula, it is a times 1 minus r to the n plus 1 over 1 minus r. So 2 over 5 is a times 1 minus -4 to the n plus 1, n is 7, plus 1 is 8 over 1 minus r. right? So that gives us 2 over 5, 1 minus negative 4 to the 8th power. We have that 6, 5, 5, 3, 5. Bottom is, that is 5, right? 1 minus negative 4, so that plus 5. Right, and we just divide this by, okay. So the top we multiply that by 2. And then divide by 25. It will be 1 fraction, that. Okay. So I think it's better just cancel this with 5. Right, so we have that. And then times 2. So we have negative 26,214 over 5. Right, which is that. Now, of course, if we want to use the calculator, math, go down to option, summation. I'll use x instead of index I. I'll go from 0 to 7. And here we have a fraction, 2 over 5. And then times negative 4 raised to the index. Right, that's what we have. Right, now we have a geometric series. So this is series, meaning infinite series. So the sum of infinite series, a little thing though, s of n. So we stop at the n term. For the infinite series, we're just going to write s. So in general, the form will be a times r to the n to the k where k go from 0 to n, infinity, and that will be equal to, depends on r. If r is between negative 1 and 1, there's a formula for it. It is divergent or does not exist if it's otherwise. So this is equal to a over 1 minus r. That is if absolute values of r less than 1. And it will be equal to does not exist. It does not exist if r absolute value of r greater than or equal to 1. Right. And of course, when r absolute value of r less than 1, meaning that it is between negative 1 and 1. Right. Now just go back to our problem. The sum of the first n term of geometric sequence. Now, r, if it is less than, if it is between negative 1 and 1, that raised to an infinity power will go to 0. So that term will go to 0 if r is between negative 1 and 1, right? Like if you take 1/2 and raise to some power, the bigger the power, the smaller that will be. So we just have 1 on the top, multiply a on the top, so a over 1 minus r. So actually that formula, of course, come from this. Right, so make sure we have that condition. Right, first, this is a geometric series. So we know the first term is 1, so we know that. And R, the ratio is whatever the ratio is, what we need to multiply from the first to get to the second term. So what we see here is this, the ratio is -7. Right, multiply -7 to go from this term to the next. And is that between -1 and 1? Always have to check that. And the answer to that is no. It's -7. So we say that this is divergent. So we say this one diverges. Right, so this is the formula for that. And of course, as always, the formula we have is on that side of the screen. Yeah, this one. Now, the thing about the formula, we have to have in the right form to use the formula. So we go from 0 and we have a times r to the n. So we have to write exactly like that. Right, so for this problem, first we check the 5 outside. And index go from 0 to infinity. I said we check the 5 in front. And then if we check the 5 in front, there's only 1 on the top. Now 1 over 3 to the n. We can say 1 to the n also, because anything 1 raised to any power is still 1. So we have n equal to 0, infinity, 5 times 1 over 3 to the n power. And as always, check to see if it is between -1 and 1. And in this particular series, a is 5 and r is 1 over 3. And so r 1 over 3 is between -1 and 1. So we check. That's good. So the formula just equal to a over 1 minus r. So 5 over 1 minus 1/3. 1 minus 1 over 3 is 2 over 3. Divide fraction is multiply reciprocal. Instead of 2/3, it will be 3/2. And so that gives us 15 over 2. Right? So once again, as long as it is in the right form, we can use that formula. Of course, with r is between -1 and 1. Right, now we take a look at this. So almost as that. So the r will be the same. However, like I said, in order to use any formula, it have to be in the right form. So the form have index equal to 0. So if we want the index to be 0 and we start from n equal to 1, and if we want 0, we just simply subtract 1 on both sides. So we have n minus 1 is equal to 0. Right, so we can do that. Now, in that case, let k be n minus 1. If that is the case, we can solve for n. So n equal to k plus 1. And we will use this substitution. Right. Substitute n equal k plus 1 into everywhere we see n. We put k plus 1. By the way, with that substitution, only works for the infinite series. If it is like this, then we might have to. If it is infinite, if it is finite, then the upper limit will need to change. Right, so we don't have to worry about that if it go to infinity. Right, now -1. Again, n is k plus 1, so just k plus 1 for n, and then -1. Then we have 3, then 5 to the n, which is k plus 1. Every time we see n, that's k plus 1. Right, now simplify this. -1 on both sides, we have k equal to 0 to infinity. -1. K plus 1 minus 1, that to the k. Now we have 3 to the 5 times k plus 1. Right. Once again, it have to be in the right form. That form. So we have something, a constant, and then something to the k. So the -1 to the k, I put that on the top, and the 3 I move in front. Right? We move from the -1 here to the k on the top. Right, now we need this to the k. So 5 to the k plus 1, we can write 5 to the k times 5 to the first. And of course the formula of that is of course we can go from right to left or left to right of that equation. This time we go from the exponent is the sum turn into a product. Now the 5 here doesn't have the power of k, and we move that will be below the 3 here. Bottom line, I want to put both of this under the power of k. So 3 over 5 to the first, or just 3 over 5. And now -1 and 5, both of them under k. So I can write like this. And then so it is in the right form now. Just make sure that the ratio is between -1 and 1. So for this particular problem, A is 3 over 5 and R is -1 over 5. So yes, it is between -1 and 1. So we can use the formula, which is A over 1 minus R. A is 3 over 5 over 1 minus R, 1 minus -1/5. So 3 over 5. Right, 1 minus, that turns into a plus. So 1 plus 1/5 is 6 over 5. Multiply reciprocal is 5 over 6. And that is 5 and 5 cancel, 3 over 6 is 1/2. Right. So of course we cannot put infinity in the sum, but we can put a very big number into it. Let's go to 100. Right. Oh, sorry. I just type the original series times fraction of 3/5 raised to the n power, right? Yeah, it's 1/2. As you see, only the first 100 term and the calculator get the very good approximation is 1/2. Of course, this will equal to 1/2 when it go indefinitely. Right. Next, I spread this number as a ratio of two integers, so fraction pretty much. So how do we do this? Right. So that first we can write this as the sum 1.36 plus 0.0036 0.000036 and so on. Now what we see here is we have this. If we multiply by 0.01, so obviously here from we can see that or to go from this term to the next is multiplied by 0.01, but not quite the first one. If we multiply 0.001, the one on the in front, that will be a problem. So we have to split as follows: 1 plus 0.36 plus 0.0036 . Now excluding the 1, the rest here, this is a geometric series. It is geometric series where the first term is 0.36 and the ratio is 0.01, and as always we check the condition if it is between -1 and 1, so we can use the formula. So in this case it is so just plus a over r, a over 1 minus r, sorry, r is 0.01. So that's what we have. 1 plus 0.36 over 0.99. Move the decimal two places to the right. We have 36 over 99. Of course, we can reduce this as divide by 3 or by 9. Cancel 9 top and bottom. 4. 99 divided by 9 is 11. So times that, so that will be 15 over 11. Of course, the ultimate way to check, just do this. Yeah. Right. So that's nice and all. Another way to do this, of course, we use the proof limit. This proof. So let's start with 1.36, 36, 36. I will let s be equal to that. Now, if I multiply by 0.01, that will be the same thing, or even better, multiply by 100. The reason I multiply by 100 because this time there are 2 digits repeating. So that's why we put 2 zeros here. So it will be 1 and then followed by 2 zeros. So that's 100. So if there's 2 digits repeating, we multiply by 100. 3 digits repeating, multiply by 1000, and so on. Now I multiply by 100 s. So this will be 136.363636, and so on. Now if I take this, subtract the top, or I just change both of them to negative, 100s minus s will be 99s. 99 times the sum, and we subtract this, all the decimal cancel out. That gives us 135 over s. So we have s is equal to 135 over 99, and 135 is divisible by 9. It gives us 15 over 9, 15 over 11. Right, so that should be the same thing as before. Of course, the way we do this is similar to the proof here. Right. Next we have determine if the series converges or diverges. If the series converges, find the sum. Right. So one thing on this test, when I ask you to find the sum, if we look at everything, all the formula we have here, none of the series give us the sum. We know it is convergent or divergent only, except for the geometric series, there is a formula for the sum. So on this test, if we ask for the sum, it is either geometric series, unless of course it's out telescoping series. So only 2 series that have the sum, geometric series and a telescoping series. All of those other series, we do not know the formula for the sum. Right. So we know that the question asks for the sum in this problem. So it has to be geometric series or telescoping series. Right. It doesn't look like geometrics, which have something to the n power. So this have to be the telescoping. Right. Telescoping series it is. So telescoping series, one of them is positive and one of them is negative. We don't have that. So the way to do that is just do the partial fraction of this one first. So partial fraction. This is a long problem, so try to write very small. So we start with this. And we split that. And now multiply by n times n plus 3 on both sides. So that gives us 4 equal to a times n plus 3. Because if we multiply by n times n plus 3, the n and n cancel out. And that gives us n plus 3. And now multiply by n plus 3, n plus 3, n plus 3 cancel out. That gives us an n. Now this is easy. We just need to say when n equal to 0, that one cancel. We have 4 equal to a, n equal to 0. Right, so that's what we have. So 3a is equal to 4. So a is 4 over 3. Now when n equal to negative 3, okay, I should put b times 0, so we put 0 for n, and that one gone. Right, next put negative 3 in for n, so that one gone. We have 4 equal to negative 3b, so b is negative 4 over 3. So that is our partial fraction. So with that, we can write the term in the series as 4 over 3 for a over n minus 4 over 3 n plus 3. Right, now for this, let's just simplify this a little bit. Write that over 1 multiplied reciprocal, so we can say equal to 1 to infinity 4 over 3 times n minus 4 over 3 times n plus 3. Right, so that's the telescoping series, which is 1 positive, 1 negative. Now let's write out the sum. Going from 1, if we put 1 in, we have 4. Just don't multiply it out, just say 3 times 1. And then minus 4, 3 times 1 plus 3. So that is when n equal to 1. Now for n equal to 2, two plus 3. Right, and we see here there's nothing cancel out yet, so we need a lot more terms. 3 times 3, and then minus 4, 3 times 3 plus 3. Again, none of them cancel out yet. Now n equal to 4. Plus 3. Is there anything cancel out yet? Well, now we see 1 cancel out. That one remaining, that one remaining, that one remaining. This one cancel with this one, right? 1 plus 3 is 4. So I'm just going to put that in the box. And this cancel out. So for the first 4 terms, it will cancel out that. So 1, 2, 3 terms remaining here. That does not cancel with anything. So remember the example we did in class with the dominoes. Think about this. For each term has a positive and a negative. Every time we cancel out, we cancel 1 positive term and 1 negative term. So when we cancel like that, at the end we still have the same number of positive terms as the negative terms. Because of that, since we have 3 positive terms from the beginning will remain, there will be 3 negative from the last 3 terms till the end. Alright. So now if we go up to n or only, so just keep going. Now we need the last 3 terms. Now we're going backward. Let's see if this one will go to n. Oh no, we cannot use n. Let's use a k, for example. Remember. Now let's instead of say the n, we go to k. So at when we substitute k here, we have 4 over 3k minus 4 over 3 times k plus 3. So that is when k n equal to k. So we need the term before that is 4 over 3 times k minus 1 minus 4 over 3 times k minus 1 plus 3 k plus 2. And now the term before that, 3k minus 2, and then 3k minus 2 plus 3, so k plus 1. Right, so that's 3 negative terms if we stop at k. So I'm going to write that we're going to have up to k should start from here, k minus 2, 3k plus 1 plus then that. So we just have to stop at a number at random. I mean not random, but we use some numbers here. I use k because original we have n already. We cannot use n. And then that. Right, so we do that. Let's keep going. Now if we only stop at k, meaning that if we only stop at here, so where the index is equal to k, I mean index equal from 0 from 1 to k. If we all go up to k only, that means we go up to this term. Right? Now, remember, we did say that if it's 3 positive term, 3 positive from the first 3 terms, then we need 3 negative from the last 3 terms. So the first 3 terms is 1, 2, and 3. So 4 over 3 plus 4 over 6 plus 4 over 9. And everything else in the middle we cancel except the last 3 negative terms. So what remaining is the 3 negative term. So depends. In this one we do have 3 positive from the first 3 terms. That means we need 3 negative from the last 3 terms. Now, as k go to infinity, all of this go to 0. So we just have those fractions. 4 thirds plus 4 over 6 plus 4 over 9. Right. So for the telescoping series, we have to do the partial fraction, and we should have 1 positive and 1 negative. So each term we have a positive, and each term in the sequence have the positive part and the negative part, and depends how many we cancel out. If we have some number of positive or some number of negative from the beginning, then we have the same number of the opposite side at the end. So that's what we have. So 22 over 9. Right, so that is that. Next, we have the divergent test for the following series. So divergent test, just by the name of it, it only tests for divergent. So divergent test is right here. It says that in the note, it cannot prove convergent, it only proves divergent. It says that what is the limit of the n term. So for the divergent test, we have to find what is the limit as k go to infinity. So all the books use the n term test. In our book, we use divergent test. The same name. Right, so we just find the limit as k goes to infinity of k cubed over e to the k. Now, of course, we can find the limit, but in this case, we just look at the roll rate there. So the roll rate, we have n to the p, where n is the index raised to a power constant. So that is the power. Remember, the index raised to some power, some constant power, is going to be less than, we have index raised to some power, constant power, is going to be less than an exponential function. So because we have e to the k is fast, go to infinity faster than k cubed, so this one go to 0. Right? So once again, the top go to infinity slower than the bottom. So if we have number at the bottom that go to infinity so fast, the top, of course both of them go to infinity, but the top will go at the slower rate. Because of that, we have the smaller number divided by a very big number at the bottom, that go to 0. Right, now if it is equal to 0, let's say that it is inconclusive. Meaning that this test doesn't work, we have to use some other test. And the other test will be, there are a lot of things like comparison test or ratio test will work. But if we use divergent test, it cannot tell us anything here. Right, to the next one. Now, as always, we try to find the limit as for pretty much find the limit of the sequence. This is n, right? So use n. So we need to find that limit, and so we write limit as n goes to infinity of n over n plus 7. Right, n go to infinity, infinity plus 7, still infinity. So what I'm saying here is that as n go to infinity, the plus 7 is negligible. So we just have n over n, pretty much. The limit is equal to that. So it would be wrong if we write, it is wrong if we say n over n plus 7 equal to n over n. The reason we can write they are equal because of the limit. So this is wrong. With the limit, it will be correct. Right, the n over n is 1, so this is just 1. Now, if the n term is not 0, that means it is divergent. Think about this. We have a series that go on indefinitely. If we know that it will never go to zero, that means the sum is constantly changing. We just keep adding something to it, and that something is not zero. So that will change. Essentially, that will be divergent. So if we have a series and we add zero to it, that doesn't change the series. But if we add something different every time, this series, the sum will change, and because of that, it does not convert to anything. So we say that is divergent. Right. Next, let's look at this one. Use the integral test to determine whether the series converges. Well, this one, of course, we can use the integral test, or we can also use forgot to write the timestamp for that last problem. Right. We instead of using integral test, we can also use the p-series. P-series is just like a subset of the integral test, but I'm just going to use integral test here. So for integral test, note the fine print here. Right, for the integral test, make sure the function is continuous, positive, and decreasing before we can find, and then before we can use the integral test. Right, so this is the term square root of n. So I'm going to let f of x be 11 over square root of x. Now, is this function positive? I mean, it should be at continuous first. So is that positive, continuous, and decreasing? So obviously, it is continuous, because that is defined for n greater than 1, right? So for k, for x greater than 1. So it is continuous, and it is positive, because square root must be positive. Square root of positive is positive, and it is decreasing because as x gets bigger denominator, smaller quotient. So that quotient will get smaller and smaller as the bottom gets bigger and bigger. So yeah, all of that checked. That means we're going to find the integral from 1 to infinity of f of x dx. F of x is 11 over square root of x. So we just need to use improper integral here because we have infinity. So replace that infinity by the upper limit. So use b. So that takes care of the limit, the improper part of the integral. Now, square root of x is x to the 1/2. X to the 1/2 at the bottom, move to the top, x to the negative 1/2 dx. Now, that's just simple integral. X to negative 1/2, so plus 1, 1/2, negative 1/2 plus 1 is positive 1/2 over 1/2. Right? Negative 1/2 plus 1 then divide by 1. I mean plus 1 and then divide by the same thing, sorry. So divide by 1/2 is multiply reciprocal 2 over 1 or just 2. Right, divide by 1/2 is multiplied by reciprocal of 2 over 1. Right, so that gives us 22 x to 1/2 square root. So put b into it. Now as b go to infinity, this go to infinity. As b go to infinity, infinity minus 22, so it is still infinity. Because of that, this integral is divergent. So we say the integral is divergent. Divergent. And if the integral is divergent, the series is divergent as well. Divergent. Right. So the series is divergent. However, we do not know what's that equal to, but we know that is divergent. This one, it is divergent. So suddenly the series is divergent, so there's no sum for that. Even though if we can find the sum, if the series is convergent, we can also only tell that it is convergent. And the note that the values of the integral is not the same as the values of the series, so that summation is not the same. But they behave the same in the sense that if one converges, so is the other. If one diverges, the other one will also diverge. Right. Now we look at this one. The term of the sequence. I'll use n in this case. Okay, it should be n, right? Sorry. Cosine of 1 over n over n squared. Right. Equivalently, we write this as a function cosine of 1 over x square. Now there will be 3 boxes. We need to check, is that positive? Is that continuous? I should say, is that continuous first? Continuous positive, and is that decreasing? Well, by the way, if I ask you for the integral test, that should be the case, because if the answer is we cannot use integral test, then that's really not much we can do here. Right, so obviously this is continuous for x greater than equal to 1, because if x equal to 0, it's not defined if x equal to 0, but for x greater than 1, it will be equal to 1. Sorry. Yeah, it has the equal sign. So it's continuous. It is that positive as x go to infinity 1 over x. Right? So 1 over x is going to be between 0 and 1, right? Think about it. We have a number that is from 1 to infinity. If we divide by something, I mean divide from, now consider 1 over 1, and then infinity 1 over infinity, right? We divide. Take 1 divided by 1 is 1. 1 divided by infinity is 0. So whatever we have here is between 0 and 1. If we have between 0 and 1 on the top and x squared at the bottom, x is positive. Both of them are positive. So cosine of anything from 0 to 1 is positive. So it's positive. By the way, 1 is 1 radian. 1 radian is about 57 something degrees. So cosine of that is positive. So from 0 to 57 degrees, or from 0 to 1 radian, cosine is positive. So that's why we have positive. And in terms of show that it is decreasing, we have to use derivative. But another way to see that is x squared goes too fast to infinity. Right. And let's look at the function, the cosine function. Going like that, from 0 to pi over 2. Pi over 2 radian is 1.57 radian. But we did say that 1 over x is between 0 and 1. So we only have like this part to go from 0 and 1. Now, I mean in terms of 1 radian. But as far as concerned, the bigger values of x, there will be the smaller number of 1 over x. And so actually just, so cosine, we start from when x equal to 1. Let's look at that. Cosine of 1 is whatever that is. And then we just, when x equal to infinity, we have from that point going backward very slowly to 0. Now, but the bottom is x squared. So the bottom, of course, if x squared go very fast to infinity, but of course the best way to show that is use derivative. And I won't have enough space here, but so let's say that also decreasing. Right. Now we just do the integral. Like I said, the proper way to show that is showing the derivative. I've just run out of space here and run out of time in that videos, so I don't want to spend too much time on finding derivative of it. You can verify that yourself. But on the test, if I ask for the integral test, that should be something simple enough that we can verify quickly. Even if we have to take derivative, it will be quickly done. Because even the integral here is not easy to do. The first thing we know that it is an improper integral. Right, how do we integrate this? Well, usually if we cannot integrate the first two things that we look at, substitution. If substitution doesn't work, the integration by parts. The other technique like integration, trigonometric integration and trig substitution, those are special case, and we usually know exactly when we see the integral form. So here we have an x squared and cosine, two different kinds of function. Usually that is substitution or iteration by parts. Let's try substitution. If we let u equal to x squared, the derivative of x squared is 2x. Well, that doesn't cancel here. If we let u equal 1 over x, which is x to negative 1, the derivative of that is x to negative 2. So that is a chance to cancel with x to the second here. Right, so the substitution, let u be equals 1 over x. Just take derivative. 1 over x is x to negative 1. Derivative is x to negative 2, which is 1 over x squared, right? Move to the bottom, x squared. Now cross multiply, we have x squared du equal dx. The x to negative 2 is 1 over x squared. Cross multiply. So x squared du is equal to dx. Right. Also here we have the limit from 1 to b. So when x equal to 1, u equal to 1 over 1, which is 1. When x equal to b, u equal to 1 over b, which is 1 over b. Now the limit changes. Step 1 to b, it goes from 1 to 1 over b. Here we have cosine of 1 over x, which is b. X squared dx is x squared du. Right. So it works out perfectly. X squared cancel out. We just have that cosine of b. Sorry, cosine of u. Du. Right, perfectly. It's perfect that we have everything in terms of u. So cosine, integral cosine is sine. Now we put 1 over b into it. And put 1 into it and subtract. Now as b go to infinity, sine of 1 over b, 1 over infinity is 0. So this approaches sine of 0, and sine of 0 is equal to 0. Right? And that minus sine of 1. So that's what we have. Right. So okay, of course there's something wrong here, right? Now we did say that, of course there's a way to check this. We said that all the terms are positive. If the answer, why can it be sine of 1 is negative? So it's impossible, right? So when we do that, we know there's something wrong here. And of course, the mistake here was obvious. If u is 1, x to negative 1, derivative is negative. Take negative 1, original power minus 1, so that should be negative. So I forgot the negative. So just take the negative outside. That turned into positive. So as you see, when we do this, all of the terms are positive. The integral cannot be negative. So that's where we know that I did something wrong there. So good, come back and check it. But regardless, we have a finite number here, a constant at the end. So this is convergent. The integral is convergent, so the series is convergent as well. The integral is convergent. The integral converges. So there's the series. Yeah, that's what we get. Yeah, like I said, the values here have nothing to do with the values here. The value here is for the integral. The values here is the summation. They're not the same. However, Schulman says that in the integral we have all of the function here is positive. We still expect to have a positive answer. But regardless, the integral converges. The series also converges. Next, determine the convergence of the series. So for this one, of course, we can use the integral test as well. But to make things simple, we move the k to the 8, negative 8/7 to the bottom. And what we see here is this is the p series. So for p series, if p is bigger than 1, it's convergent. And if it's less than or equal to 1, it's divergent. So this is the p series. And p is 8/7. In this case, it is bigger than 1. So that means it is convergent. Right, so that's simple enough. That's it. Next, use the root test to determine if the series converges or diverges. So the root test is pretty much we take root test here. We take the root of k, and if that equal to something less than 1, as k go to infinity, that is convergent. If it's greater than 1, it is divergent, inconclusive if it's equal to 1. So usually when we use the ratio test is where we have the whole thing raised to the power like this. So just go ahead and take derivative. Right. So for the root test, we're going to write out the term of this is n. Right. Now ratio test, the root test, if we take this to the n root. However, for an even root, we throw an absolute values here, so we don't have to worry about the case where we have a negative square root of a negative number. Right, see what happened. So we do that with the root test. Okay. N goes to infinity, the n root of ln of n over 3n minus 8 to the n power. Right, all of that in the absolute values. So just I can also just say it, that term to an absolute values. So that's guaranteed to be. So for example, if I say it negative 3 to the n power absolute values, that is the same as negative 3 to the n power, right? Because it's going to be positive at the end. So that's what we have. Next. Right, now the power of n here, square root, we can write that as one over n, right? Right. And now power to another power, multiply them. So pretty much the root cancel the power. We can just say that. I'm just going to say it ln of n over 3n minus 8. Originally to n, now we multiply 1 over n. N and n cancel out, so that's just to the first power. So bottom line is the root cancel the power, or the n cancel the n here. Right. So ln of n over 3n minus 8. So if we look at the roll rate, the ln is the one that's slowest to infinity. It still go to infinity, but at the slowest rate. 3n, of course, will go faster to infinity. So the bottom go faster than to infinity than the top. So that will be 0, right? So the bottom gets bigger and bigger so fast. The top still get bigger, but at a much slower rate. So that have to go to 0. And ratio test says that, the root test say that if it's less than 1, it is convergent. So this one is convergent. Because here we say 3n minus 8, or just n is greater, go to faster than ln to infinity. Right, next we have this one. Well, is that 10 to the n and then square, or 10 to n square? Bottom line is, which one we're looking at? Is that 10 to the n square is a power, or do we have 10 to the n and then square? Actually, we just do both. Right, now for this one, remember power to another power. This is 10 to the 2n, and here 10 to the n square. So n squared is just n times n. Right, so that is the difference. Of course, 10 to the n times n is a lot bigger than 10 to the 2n. Right. I said we're going to do both. And the root test. So now, first, we're going to use the ratio test for. By the way, on the test, if I ask this question and if it's not clear, please ask. Otherwise, I should clarify that on the test. So what we want. So first, let's say that we're looking at the 10 to the n square, where the n square is on the exponent. And I will rewrite n square as n times n, because that's what n square means. Right. Then we just take the root, the n root. Once again, everything when we see the power of n, that the root test is a good choice. Right. Right, so we do that. Now, of course, the n root is the power 1 over n. Now we will take that power, go to the top and then go to the bottom. We should maintain the absolute values. Do we need the absolute values? Nah, because 10 to the n times n, that's positive. The bottom is positive. So absolute values or not, it doesn't matter. It's positive anyway. So the root doesn't matter, like that. This one doesn't matter. And then we have n to the n to 1 over n. Right. I said power 2, not a power, so we multiply n times 1 over n. At the bottom, n times 1 over n. That cancel out, and we have n and 1 over n cancel out. We have 10 to the n on the top. At the bottom, n and 1 over n cancel out. We have n. Now, 10 to the n power, that is exponential function. Exponential function go faster than to infinity than a linear function. So, actually, any exponential function go faster than any power function. Right? So 10 over n, 10 to the n, go to infinity a lot faster. So because of that, if we have something on the top getting too big, the bottom getting bigger but at a much slower rate, this will have to be equal to infinity. Because the top getting to infinity so fast, and infinity is greater than 1. And the root test says if it is greater than 1, it is divergent. Right, now on to the other case. Now, if a sub n is 10 to the n and then square. Right? And because when we say that means power to another power, so we'll multiply them. N times 2 to n. Right, root test. Once again, we really don't need the absolute values here because of the numbers here are positive when n is positive. Oh, I forgot. Whether we put absolute value or not, it doesn't really matter here. But the root of n we can say is to the 1 over n power. Right, so that power goes to the top. And go to the bottom. And power to another power, we multiply the powers together. Like I said, the absolute values we don't really need because all of them are positive. 10 to the 2n times 1 over n. 1 over n cancel out. Right, and I mean, just multiply the power together. So n cancel out, we have 2. At the bottom, and an n cancel out is n. So this is the limit as n go to infinity of 100, which is 10 squared over n. Now, 100 over n, as n go to infinity, a finite number divided by infinity is equal to 0. Right? The bottom getting bigger and bigger, where the top is constant. So the bigger the denominator, the smaller the quotient. Essentially go to 0. 0 is less than 1. So by the ratio test, it is convergent. Right, so that is the root test. I will stop this video here, and we continue on the second part of on another part of the review. Thank you for watching.